Hey there, Dr. Flux here again, and welcome back to Module 5 of General Psychology. Last time, we zoomed in real close to check out how neurons fire and pass messages along. But neurons don't work alone. They're part of a much bigger system, connecting every part of your body to your brain. So today, we're zooming out to see the bigger picture. We'll explore how the nervous system is organized, how the brain serves as your personal command center, and how messages are constantly flying back and forth to keep you moving, thinking, and reacting to the world around you. Let's do some review from our last lecture. First up, what happens if inhibitory signals outweigh excitatory signals in a neuron? A, the neuron fires an action potential. B, the neuron does not fire. C, the neuron fires twice as fast. D, the neuron releases more neurotransmitters. The answer is B. If there's more inhibition than excitation, the postsynaptic neuron will not fire. Let's look at another one. What is the threshold voltage after which an action potential is sure to occur? Remember, it's an all or none signal. A, positive 40 millivolts. B, 0 millivolts. C, negative 55 millivolts. Or D, negative 70 millivolts. The answer is C. Once the voltage at a neuron soma exceeds negative 55 millivolts, it's committed to firing that action potential, starting at the axon hillock. So what's on the map for today? First, we'll look at the nervous system as a whole, the incredible network of neurons that connects every inch of your body to your brain. Then we'll zoom in to the brain itself, breaking down how it's organized to handle everything from breathing to problem solving. After that, we'll see how signals travel to and from the brain, because communication is a two-way street. From there, we'll explore reflexes, those automatic responses that happen before your brain even knows what's going on. And finally, we'll dive into how your nervous system handles stress and relaxation with the sympathetic and parasympathetic systems, your body's way of balancing action and rest. And here's the big question we're tackling today. How do the brain and nervous system work together to control everything from reflexes to complex behaviors? Think about that last time you had to react instantly. Maybe dodging a rogue frisbee on campus or grabbing onto a railing when you slipped on an icy sidewalk. Or think about the last time you were deep in thought, making a big decision about your future. Whether it's automatic or intentional, your nervous system is behind it all, orchestrating the show. All right, let's get moving. First stop, the nervous system. Incredible network that connects your brain to your body and back again. Think of it as your body's high-speed highway system, keeping everything running smoothly. We'll start with the central nervous system. This is your brain and spinal cord. It's the command center of your body, processing everything and deciding how to respond to our environment. Beyond that, we have the peripheral nervous system. This is everything outside of your brain. The PNS connects your brain and spinal cord to every part of your body, making sure our actions sync up with our intentions. Now, the peripheral nervous system is split into two parts. The somatic nervous system, which is all about voluntary movement. Every time you decide to move from crossing the street to climbing a cliff face, that's your somatic nervous system at work. It's continuous, deliberate, and driven by your choices. The autonomic nervous system, that's your autopilot mode. It keeps your heart beating, your lungs pulling in air, and your body temperature regulated. You don't have to think about it, it just happens. I tend to think about things in terms of club metaphors, so here's how I see it. The central nervous system is like the DJ booth. It's where all the beats are mixed, filtered, and controlled. The DJ is constantly reading the room, adjusting the tempo, and deciding when to drop the track that makes everyone lose it. The peripheral nervous system, that's more like the dance floor. It's the crowd moving in sync, feeling the beats in their bones and sending that energy right back to the DJ. It's a loop, at least if the DJ is good. The DJ sets the tone, the crowd responds, and then the feedback from the dance floor influences the next track. That's how your body works. Your brain processes, your body reacts, and the loop keeps it all spinning. Let's do an attention check. Which of the following is part of the central nervous system? A, the nerves in your hand. B, your heart. C, the stomach. Or D, the brain. If you said D, the brain, you nailed it. The central nervous system is the command center. It's the DJ booth controlling the entire vibe. The nerves in your hand, that's part of the peripheral nervous system, responding to the beats and then sending signals back to the brain. The crowd and the DJ booth all working together. We've talked about the nervous system as the body's communication network, but now it's time to zoom into that actual command center, the great DJ that is the brain. This is where everything comes together: thoughts, emotions, movement, and even the most basic functions that keep you alive. The brain isn't just one big blob of neurons, it's highly organized, with different regions responsible for specific tasks. Understanding how the brain is structured helps explain everything from how you breathe to how you solve complex problems. The brain is organized into 3 major regions. The hindbrain. This handles the basic life functions that keep you alive, like breathing, heart rate, and balance. You don't have to think about it, it just happens. Then we have the midbrain, which acts as a bridge between the basic functions of the hindbrain and the higher level functions of the forebrain. It helps coordinate your movements and processes sensory information like sight and sound. The forebrain is where things get complex. The forebrain is responsible for higher level processes like cognition and decision making. It's where your personality, creativity, and memories live. Let's take a look at each of these systems in turn. Starting with the hindbrain. It's the part of your brain that keeps you alive without you even noticing. It involves the medulla, which controls your heartbeat and breathing. Every breath you take, every move you make, your medulla is watching you. The pons connects different parts of the brain and helps coordinate movement. It's like the brain's internal messenger, making sure everything stays in sync. And then we have the cerebellum. This handles balance and coordination. Whether you're walking, running, or even typing on your laptop, the cerebellum keeps your movements smooth and steady. Next up is the midbrain. This part of your brain connects your brainstem with the rest of your brain. It processes sensory information, like what you hear and feel, and coordinates it with your movements. It's made up of the cerebral peduncles, the tegmentum, and the tectum. Think about the last time you were in a crowded room, maybe at a concert or a busy cafe. You could hear the music, feel the vibrations, navigate the space without bumping into people. Your midbrain made sure your senses and your movements were perfectly aligned. Now let's move on to the forebrain, where the deep thinking happens. The cerebral cortex is responsible for higher level thinking, planning, and creativity. It's what allows you to solve problems, plan for the future, and reflect on your experiences. The limbic system was historically how we thought about the emotion centers of the brain, processing feelings and memories. However, more recent neuroscience discoveries have called this categorization into question, which is something I dive into in some of my higher level courses like human emotion. The hypothalamus, which is included in the limbic system, manages your body's internal balance. It regulates things like hunger, thirst, and body temperature. It's why you feel thirsty after a long run or start to sweat when you're nervous. Take a moment to reflect. Think about the last time you were fully immersed in something, whether it was solving a challenging problem, experiencing a powerful emotion, or just going about your day. Your hindbrain kept you breathing and your heart beating. Your midbrain processed all the sensory information around you, helping you stay aware of your environment. And your forebrain, that's where your thoughts, emotions, and decisions came together to shape your experience. All right, now that we've explored the brain's command center, it's time to look at how it communicates with the rest of the body. This is where afferent and efferent signals come into play. Your nervous system is like a two-way street. One direction brings information into the brain, and the other sends instructions out to the body. This constant back and forth keeps you moving, reacting, and adapting to the world around you. Let's break it down. Afferent signals are sensory signals. They carry information to the brain from your body. Every time you touch something hot, hear a sound, or feel a change in temperature, those signals are traveling up to your brain to let it know what's going on. Efferent signals are motor signals. They carry instructions from your brain to your muscles and glands. When you decide to move your hand away from something hot or start tapping your foot to a beat, that's your brain sending efferent signals to make sure it happens. Here's an easy way to picture it. Imagine your body is like a building with a high-tech fire alarm system. The smoke alarms are like the sensor receptors in your body. They detect heat, smoke, or any signals of danger. When they pick up something unusual, they send a signal to the control center, that's your brain. This is an afferent signal, bringing sensory information from the environment to your brain. Now, once that control system processes the information and decides it's a real threat, it sends a command to activate the sprinkler system. The sprinklers kick in, spraying water to put out the fire. This is an efferent signal. instructions sent from the brain to the body to take action. Let's do another attention check. Which type of signal carries information to the brain? Is it A, an afferent signal, B, an efferent signal, C, a reflexive signal, or D, an autonomic signal? If you said A, afferent, you've got it. Afferent signals are all about bringing sensory information into the brain, just like that smoke alarm sending a warning to the control system. Efferent signals, on the other hand, are the commands sent out to take action, like activating the sprinklers. All right, now that we've covered how signals travel to and from the brain, here's a twist. What if your body could react before the brain even gets involved? This is what happens with reflexes. Automatic, lightning-fast responses that keep you safe without you even thinking about it. So what exactly is a reflex? Reflexes are automatic responses that your body makes without you having to think. They're your body's way of protecting you from danger. These responses are controlled by the spinal cord, not the brain, and that's why they're so fast. Your body doesn't wait for the brain to process what's happening. Reflexes help protect you from harm. By the time your brain realizes something's wrong, your body's already reacted. Let's put this into context. Imagine you accidentally touch a hot stove. The sensory receptors in your skin detect the heat and pain and send a signal to your spinal cord. Instead of waiting for the brain to process this, the spinal cord immediately sends a signal back to your muscles, telling you to pull your hand away. By the time your brain even registers the pain, your hand is already off the stove. This quick, automatic response is what makes reflexes so effective. They keep you safe in situations where every millisecond counts. The whole process, to take a deeper look, is called a reflex arc, and here's how it works. This image is looking at a cross-section of the spinal cord. A stimulus is detected by sensory neurons. This is an afferent signal bringing information to the spinal cord. The signal reaches the spinal cord, which acts as an integration center. The spinal cord then sends a message through motor neurons. This is an efferent signal telling your muscles how to respond. The body reacts before the brain even has a chance to process the stimulus. It's like your spinal cord saying, "No time to think, just move, now." Think of reflexes like the automatic emergency brake system in a car. When a car's sensors detect an obstacle, like a pedestrian stepping into the road or maybe the wall of your garage, the system slams on the brakes before you even realize what's happening. Reflexes work in a similar way. Your spinal cord is the car's sensor system, detecting danger and triggering a response instantly. By the time your brain catches up, the action's already happened. You've probably experienced reflexes without even realizing it. Here's a few common examples. There's the patellar reflex, which is that knee-jerk reaction when the doctor taps just below your kneecap. There's the withdrawal reflex, like pulling your hand away from a stove. And there's also the crossed extensor reflex, which helps you to maintain your balance when you withdraw a limb from something painful, like staying upright if you step on a Lego brick with bare feet. These reflexes are all adapted to protect you, and they happen faster than you can consciously control. Let's see if you're following the reflex arc with an attention check. Which part of the nervous system controls reflexes, like pulling your hand from a hot surface? A, the brain, B, the spinal cord, C, the heart, or D, the somatic nervous system? If you said B, the spinal cord, you're on point. Reflexes are controlled by the spinal cord, which is why they happen so quickly. The brain only finds out after the fact. All right, we've seen how reflexes protect you in an emergency situation, but what about the everyday balancing act between action and relaxation? That's where the autonomic nervous system comes in. It runs behind the scenes, managing everything from your heart rate to your digestion without you even having to think about it. And within this system, there's two key players, the sympathetic and parasympathetic nervous systems. These two are constantly working together to keep you balanced, kind of like having a gas pedal and a brake for your body. The sympathetic nervous system, or SNS, gets you ready for action. It's your fight or flight response, kicking in when you're stressed, scared, or excited. Think of it as hitting the gas pedal. The parasympathetic nervous system helps you relax. It's your rest and digest system, slowing things down when you're safe and calm. This is your body's brake pedal, bringing you back to balance after a period of stress. Together, they help your body respond to what's happening in your environment and then recover afterward. These two systems tend to act in opposite ways on your body. The SNS increases your heart rate and breathing, while the PNS slows them. The sympathetic nervous system dilates your pupils, bringing in more light to assess the situation, while the parasympathetic nervous system constricts them, indicating you don't need to be alert anymore. Your sympathetic nervous system slows down digestion. This is an energetically costly process, and you'll need that energy to get moving. The parasympathetic nervous system, on the other hand, stimulates digestion and recovery. Finally, all of this helps prepare your body for action. That's why it's called fight or flight, or promotes relaxation, which is why it's known as the rest and digest system. Here's a simple way to think about it. The sympathetic nervous system is your gas pedal, revving you up when you need to move fast or handle a challenge, and the parasympathetic nervous system is your brake, slowing you down when it's time to relax and recover. The body is constantly switching between these two depending on what's going on around you, similar to how you're constantly using the gas pedal and the brake when you're driving. But too much gas and you'd burn out. Too much brake and you don't get anything done. It's about that delicate balance. Take a second to reflect. Think about a time when you felt your heart race. Maybe right before a big presentation, during an intense workout, or when something unexpected happened. That was your sympathetic nervous system getting you ready for action. But afterward, the parasympathetic nervous system helped you calm down and recover. Your body is always balancing these two systems to keep you ready for whatever comes next. Here are the key takeaways from today. Your nervous system is a two-way communication highway, constantly sending messages between your brain and body. Your brain is the command center, with different regions handling everything from basic survival to complex thinking. Afferent signals bring sensory information to your brain, while efferent signals send instructions from your brain to your muscles and glands. Reflexes are your body's instant, automatic response to danger, controlled by the spinal cord and keeping you alive. Finally, your sympathetic and parasympathetic systems keep you balanced, revving you up when it's time to act and slowing you down when it's time to rest. But why does all this matter? Understanding the nervous system helps us to see how deeply connected our bodies and minds are. Every thought you have, every emotion, every movement, it all starts with neuron firing and signals traveling through this intricate network. Whether you're reacting to danger, solving a problem, or just simply breathing, your nervous system is working behind the scenes to keep you alive and engaged with the world around you. Before we wrap up, here's a couple of review questions to get you thinking about what we just learned. What division of the nervous system prepares the body for action in stressful situations? Is it A, the parasympathetic nervous system, B, the sympathetic nervous system, C, the somatic nervous system, or D, the central nervous system? The answer here is B, our sympathetic nervous system, or the fight or flight system. What type of signal carries information from the brain to the muscles? Is it A, afferent, B, efferent, C, reflexive, or D, sensory? The answer is B, efferent signals. These signals carry motor information from the brain to your muscles to get you moving. Your nervous system is in constant motion, adapting to your environment and experiences. Every sensation, every reflex, every heartbeat is part of this dynamic system that's always adjusting, always responding. By understanding how it works, you're not just learning about biology, you're learning about yourself. Your reactions, your thoughts, your emotions, they all start with the firing of neurons and the flow of signals through your body. It's a beautiful and complex system that's always in motion, always in flux. Thanks for joining me on this journey through the highways and command centers of your body. I hope you're seeing how these systems shape your everyday life, from the smallest reflex to the biggest decision. Until next time, stay curious, stay resilient, and above all, live life in flux. I'll see you soon.